Hi everyone. Today I want to talk about how to use phenomena effectively in the science classroom. Phenomena are observable events or patterns that make students stop, notice, and wonder. A phenomenon might be a video of a bridge moving in strong winds. It could be a graph showing a sudden change in population. It might be an image of a cracked road after an earthquake. Or it could be a simple classroom demonstration where something unexpected happens. The phenomena does not need to be dramatic or complicated. It simply needs to give students something meaningful to explain. First, begin by presenting the phenomena before explaining the science. Show students the image, video, demonstration, artifact, or data. Then give them time to observe it. You might begin by asking, what do you notice? What do you wonder? What patterns do you see? Or what do you think might be happening? At this point, students do not need to have the correct explanation. The purpose is to make them think about the reason and think about what is happening. It's also helpful to separate observations from inferences. For example, a student might observe that one plant grew taller than another. Saying that the taller plant received more sunlight is an inference. It's possible explanation for the observation. Helping students recognize the difference strengthens their scientific reasoning. The next step is choosing a phenomenon that connects directly with your learning goals. A strong phenomenon should connect directly to the science concepts and standards you want the students to learn. It should be puzzling enough to generate questions, but accessible enough that students can begin discussing it. Whenever possible, choose phenomena that connect to students' lives, communities, or experiences. For example, students might investigate why roads develop potholes. They might explore why a local stream becomes cloudy after rain. Or they might ask why temperatures are often different in cities than in a nearby rural area. These examples give students an authentic reason to use science. Once students have observed the phenomenon, use their questions to help guide the learning. As students observe the phenomenon, record their questions. You might create a class driving questions board, or you might simply keep a shared list of the student questions. The teacher will make instructional decisions based on these questions, but students' questions help create the pathway for the learning. Students may realize that they need to analyze data or that they need to conduct an investigation. They may need to read about a scientific process, or they may need to build a model before they can fully explain what they observed. This changes the purpose of the lesson. Students are no longer completing an activity simply because the teacher assigned it. They are using the activity to figure something out. It is also important to return to the phenomenon throughout the lesson or unit. A common mistake is using a phenomenon only as an attention-grabbing introduction. A true phenomenon should not disappear after the first few minutes of the lesson. Return to it. As students gather evidence and develop new understanding, you might ask, what can we explain now that we have more information? What evidence supports our explanation? Has your thinking changed? Or what questions do you still have? Students can also create an initial model or explanation. Then they can revise it throughout the lesson or unit. Those revisions are important. They show students that science is not about producing a perfect answer immediately. Science is about improving explanations as new evidence becomes available. As students build understanding, introduce vocabulary when they have a reason to use it. Phenomenon-based instruction does not mean that vocabulary and direct instruction disappear. Instead, vocabulary is introduced when it helps students describe or explain what they are investigating. Students are more likely to understand and remember a term when they have a reason to use it. Rather than beginning with a long list of definitions, allow students to encounter the pattern, process, or relationships first. Then introduce the scientific language that helps them communicate their ideas more precisely. Finally, ask students to use evidence to explain the original phenomenon. Students should eventually return to the original phenomenon and explain how or why it had occurred. This could be completed through a CER response. It could be a revised model. It might be an annotated diagram, or it could be a class discussion or a quick presentation. The final explanation should require students to use evidence. It should not simply ask them to repeat a vocabulary definition. You can also assess transfer by giving students a new related phenomenon. For example, after students explain erosion in one location, show them a different landscape and ask them to apply the same scientific ideas. This helps us see whether students can use their learning in a new situation. The biggest idea to remember is that a phenomenon is not just a hook. It is the reason students need the science. Effective phenomenon-based instruction begins with student observations and questions. It provides opportunities to investigate, analyze evidence, and build explanations. And it repeatedly asks students to revise their thinking. When we use phenomenon this way, students are not simply learning science facts. They are observing, they are questioning, they are modeling, they are analyzing evidence, and they are building explanations. In other words, they are working and thinking like scientists.